Okay, before we get any deeper, let me introduce myself first. My name is Manuj Agarwal. I've been in this industry for about 20 years, and even though I have been awarded multiple patents in cutting edge fields like machine learning, even though I am teaching 90,000 students across 190 countries, and even though I have interviewed more than 5,000 engineers in my career, and even though I'm a published author of 2 technology related books, there was a time and place in my life when I couldn't figure out what I was going to do to take control of my life and career. I was completely lost and helpless. You see, I grew up in a small agricultural community back in northern India where there were limited number of job or higher education opportunities. The nearest technical college was about 6 hours drive from my place. I was drenched. Every pore of my body was oozing out sweat, desperately trying to cool itself down. The thick grey smoke from the furnaces left black soot all over my face, clothes, and hands. The temperature outside was 50 degrees centigrade or 122 degrees Fahrenheit with 95% humidity. Inside, the furnaces were burning at around 1200 degrees centigrade, raging fire and heating the steel rods to bright orange glow, just below their melting point. As the red hot rods were popping out, they were stacked up. One by one, the rods were hammered by this huge double-story machine press, which dropped tons of pressure in a fraction of a second and forged the red-hot steel into humongous bolts and nuts. The deafening sound of the hammering machines and the roaring furnaces made it hard to listen to my own thoughts. That was a typical day at work for me. Believe it or not, my career started at 15 years of age while working in a factory. I worked there for 6 years while continuing my studies on the side, 12-hour shifts, 6 days a week, and I'm not telling you all this to feel sorry for me. I also learned a lot of things there. For instance, I interacted with people from various walks of life, businessmen, government officers, bank employees, and so on. All this gave me a strong foundation in soft skills. In the factory, we had to maintain strict quality standards. So I learned the importance of quality in whatever work you do. In spite of all the unique experiences, I knew I had to get out and make a better life for myself. But I had no money or resources. I tried to get a loan for higher education, but that was denied because I could not offer anything to the bank as a security deposit. In any case, I knew education was the only thing which could change my situation, which eventually it did, which is why I'm so passionate about lifelong learning and sharing the knowledge. Hey there! I just thought I will take a few minutes and give you a glimpse of my journey as an online instructor. There I was, a simple techno geek trying to make video courses and spread the knowledge which I have acquired over 20 years of my career in software and IT field. The thing is, at the time I had no idea how to make videos. I struggled a lot getting the audio right. I must have tried at least 5 mics before one worked. I did not know how to record quality videos without spending thousands of dollars on expensive equipment and getting the lighting right. You can see the logo on the white t-shirts turned out to be inverted. Anyway, I kept going and trying to figure things out. It took me 3 months to build my first course. I was so happy when the course got published. The big problem was that after the course was published, no one enrolled. Crickets. I realized I had to figure out a way to share my knowledge in a different manner. But I was already overwhelmed by the whole process of video making. If I didn't figure this out, that meant I had to put off the dream of becoming an online instructor forever. Then, as if by chance, something amazing happened. I realized the key to my success was that I had to get really good at getting constructive feedback from my audience, however small it was, and improve the content quality based on what they wanted. Instantly, it became crystal clear to me that I had to ask my learners to tell me how to provide them with the content they desired. Because I knew I was not good at making videos, but I had a lot of knowledge to share. So, if only I kept going, I could continuously and incrementally improve the quality of the content based on feedback from my students. My plan was to start increasing the quality of the content and incorporate other factors into the course content to make it a very pleasant learning experience for my students. This will be all based on feedback from my learners. I started a routine of checking the reviews and feedback every day, and I used it to improve the quality of our content. I learned how to set up proper lighting, use better cameras. I emptied out one of the rooms in my basement, which we were using as storage, and turned it into a makeshift studio. As you can see, it is still very scrappy. But I didn't stop there. I then hired professional actors with neutral accent to narrate the courses so that you can understand the content better. As you can notice, my accent is not neutral, and some learners whose first language was not English had trouble understanding the complex material. After that, we added a survey to the end of the courses so that you can provide us direct feedback easily. And I started creating new courses based on the feedback you provided. Building on that success, I decided to get really good at listening to your feedback, to become the ultimate provider of quality content which my students wanted. Not so I could become a star instructor, but because I really wanted to be a catalyst in spreading the knowledge to other people. Help my fellow engineers gain more knowledge and change their lives. I knew that my ultimate success was not about my ability to create courses, but my ability to give my learners exactly the content they wanted. With Tetra Noodle online courses, I can now create great content which may not be perfect, but will continuously improve. It will be based on direct feedback from my students. I know we still have a long way to go, but I promise to continue to listen to our audience very carefully. So please, if you notice something which you do not like or it does not resonate with you, please do let us know and we will make every effort to address it as soon as possible. Our goal is to be #1 educational provider on technology and professional development. We will get there slowly but surely. But we really need your help and feedback. With continuous efforts and hard work, I'm glad to inform you that within 2 years, we are now among the top 10 online instructors on this platform. And that's why I'm so excited to share this course with you so that you can gain this knowledge and apply it in your tech projects or professional lives as well. Happy learning!
Hello, and welcome to the course Beginner's Guide to Automation with Ansible. Software engineering is only a few decades old, but the software development and deployment processes have been constantly evolving. With the advent of cloud computing, virtualization, and plethora of scripting languages, the DevOps revolution has taken the world of software development by storm. Technology today is sophisticated, and developers are building complex software to meet the ever-growing digital demands. As a result, the industry tries to keep up with the needs and competition. In software development, it is evident that trying to run a simple project by implementing a series of manual protocols backed by instructions just doesn't work well. This manual repetition of tasks does not add value to the project or even the organization. What can be done to maximize efficiency and scale up development? Automation to the rescue. Automation saves time, money, and efforts by increasing productivity. In this course, you're going to learn about the significance of automation in software development. You will also understand how Ansible can effectively fulfill your automation needs in your day-to-day implementations. The software development and deployment processes have been transformed over the years. From simple software running on one central server to complex systems running on multiple servers in the cloud. Provisioning and managing complex server architecture across different environments can be a challenge. In most cases, this is the major cause of product releases and iterations. Traditionally, you would manually provision servers, install all the dependencies, and then launch software within those servers. This approach has its flaws. Say, if disaster strikes and your infrastructure gets corrupted or fails, to spin new servers, you have to go through the same painful process all over again. Frustrating, isn't it? But by introducing IAC, Infrastructure as Code, these things become manageable. Infrastructure as Code is the process of managing and provisioning computing and networking infrastructure and their configuration through machine processable definition files. Rather than physical hardware configuration, you can use interactive configuration tools to define, provision, and maintain your infrastructure. There are many tools such as Terraform, Puppet, Chef, Ansible, etc. that can be used to achieve this. However, in this course, we will be looking into Ansible. So, what is Ansible? Ansible is an open source automation platform that is used for configuration management, application deployment, task automation, etc. It can also do IT orchestration to run tasks in sequence and create a chain of events which must happen on several different servers or devices. In simple terms, Ansible enables us to define our infrastructure as code in a simple, declarative manner. In this course, you will get a hands-on walkthrough of various features and functions offered by Ansible. How to install Ansible, how to write our very first playbook, you'll learn the ways to use the Ansible command line, how to debug playbooks, and how to develop a playbook on our own.
In this course, you're going to learn about the significance of Ansible in today's times of technology and innovation that rely highly on automation. In this course, you'll be introduced to automation, its significance in the field of software development, Ansible at a glance, what is Ansible and what you can do with it, and key features of Ansible, what makes Ansible stand apart from the crowd. Now that you've seen the course overview, what are you expected to take away from this course? By the end of this course, you will be able to define the concept of automation and its scope of relevance in the IT infrastructure, explain what is Ansible, list the key features of Ansible, and achieve highly efficient results by using Ansible to execute software automation tasks in your day-to-day projects. Sustainable solutions like Ansible will help you scale up and achieve maximum results with minimal configurations. At tetratutorials.com, you focus on in-demand skills and real-world education. Gaining this practical knowledge and experience with Ansible will be very valuable for your career. And it will be a right step towards improving your work or project or career prospects. The more in-depth knowledge you have about Ansible, the more marketable you will be. Doesn't this pique your interest? Let's start learning. Let us start with a background of automation and automation tools. In this section, you are going to learn what automation is and how automation tools benefit the process. Automation has become quite the buzzword in IT advancement. Let's find out why. Automation is the technique of operating or controlling a process by automatic means. It simplifies complex operations and greatly reduces development workload. The basic principle behind automation is elegant, and its advantages prove it. Implementing automation in a process means human intervention is minimal. There is greater reliability and efficiency involved. What does this method signify in the field of information technology? Development and testing of IT products, such as application and cloud services, are automated to a huge extent. This reduces risk and error, and increases positive results. Automated scripts ensure the successful execution of a process, since the set of repeatable tasks in a process are taken care of by the automated function. Unless interfered, the process runs smoothly, thereby guaranteeing a successful completion. Another benefit to automating is that developers and testers can focus on the areas where they add real value to a project, developing and testing new code and features, instead of worrying about the underlying development infrastructure issues. You know that system administrators closely work with software on a daily basis. They need to add, remove, update, and monitor software regularly. Automating these multiple processes helps the administrators to ensure that everything is running smoothly. When system administrators face situations where they have to deploy large applications on multiple nodes or destinations manually, there is a high degree of risk and error involved. And this is where Ansible comes in. Let us now learn about Ansible. In this section, you're going to understand what Ansible is, its benefits, and what you can do with its components. Ansible is an automation engine. It is an elegant solution to your automation needs. It is unique from other management tools in many respects, aiming to provide large productivity gains to a variety of automation challenges. Ansible is the quickest and easiest way to automate many IT functions, such as configuration management, orchestration of software lifecycles, provisioning tasks such as installing an operating system on a remote computer, and deploying any application on top of the remote servers. You do not require advanced coding skills to work with Ansible. Your time as a system admin frees up to work on other aspects of your software management functions. You can easily configure Ansible to run and manage complex processes and functions. Ansible is a resource-sensitive platform. This means that it optimally utilizes available resources without compromising on quality of the automated task. When Ansible is not managing remote nodes, it does not run any background processes. This saves up system memory and does not overwhelm the CPU. Most importantly, Ansible is powerful, reliable, and secure, as it executes tasks in order and limits the transmission of potentially sensitive data between machines. The features of Ansible double up as advantages too. Let's check out a few of the many upsides to using Ansible. Ansible is a new dynamic tool for streamlining automation functions and complex operations. It is easy to set up and configure, which is a real advantage when it comes to handling complex processes and large-scale deployments. With its streamlined efficiency, it has proven to be a boon for IT administrators as it automates to mundane tasks of automation and system upkeep. Ansible has a huge engaging online presence in the form of a support community, with thousands of experienced members sharing their knowledge and expertise. The community aims to provide solutions and keep the world updated with the latest developments in Ansible. There are many benefits of working with Ansible. It is a pit stop for your automation requirements, especially in a secure, agentless environment. Let's take a look at some of them. These are a few of the many benefits of implementing Ansible as an automated solution. Ansible does not require any dedicated agents to work on it. It only needs OpenSSH or Python on the remote servers. OpenSSH is one of the most critically reviewed programs in the entire world, and is the foundation of secure access on their platforms. Ansible's whole architecture is structured around the concept of idempotency. The core idea is that you only run Ansible's automation as needed, and you can repeat it without any side effects. Ansible is useful in environments where different users have different levels of access. For example, developers, administrators, and QA engineers have managed access to their respective isolated environments. There is no accidental risk of a developer pushing content to production. The ability to manage systems without installing additional agents makes Ansible a consultant's best friend. It is your best bet when it comes to maintain a deployment system, because Ansible efficiently reuses connections and engages a minimal amount of internet traffic. With all these and many more advantages, Ansible is truly an icon for innovation. It makes sense to use Ansible if you aim for maximum profitability in the business of IT. With a product so powerful, handling complex processes on a large scale becomes easy. As you progress through the Ansible course, you will discover a whole new world with scores of features and attributes designed to make life easier in automation and system management. And due to these benefits and many other features which Ansible brings to the table, companies across the world are embracing Ansible. These are just some of the most recognizable names who have adopted Ansible as part of their infrastructure. Needless to say, with companies like Cisco, NASA, EA, and GoPro putting their faith in Ansible, this automation solution is here to stay. Before you get going with the course content, let's talk about some housekeeping items. To download all the resources used in this course, please navigate to go.tetranoodle.com/Ansible-masterclass. Here you will find the slides and other supplemental material for this course. So if you haven't done that already, please navigate to the URL listed above and download all the resources to your local machine. Once you have downloaded the slides for this course, you can review them from your local system, even when you are offline. This was just a glance into the fascinating world of automation, virtualization, and software management. In the future modules, you will get an overview to Ansible. You will learn how it plays a vital role in the field of automation configuration and deployment. You will be introduced to many of its practical features, all designed to make automation easier. You can take assessment quizzes to test your knowledge on these topics. These activities will enable you to apply your knowledge and improve your skills in automation. Hoping this introductory course has stirred your interest in a vast and thoroughly interesting topic. Thank you for your time. Good day.
Hello and welcome. This is the first module on Ansible configuration. This module uncovers a whole new arena of seamless automation to advance IT and business development. You will learn how to configure Ansible and some of its basic components. Let's get started.
Let's take a look at the learning objectives of this module. In this module, you will learn how to install the latest version of Ansible on the host machine, create an Ansible inventory, which holds credentials of the configured virtual machines, use the YAML format for writing inventory files in Ansible, and configure and implement ad hoc commands in the inventory files. Ansible is an effective tool that automates functions like configuration management, orchestration of software lifecycles, provisioning tasks. You do not require advanced coding skills to work with Ansible. Let's get to work. In this section, you will learn how to install Ansible on the Ubuntu and Fedora virtual machines. Before proceeding with the installation, let us review the demo environment which has been set up for Ansible. In this environment, you have 3 machines deployed. The first machine is the VMware host machine, which will also act as an Ansible host. That is where you're going to run your Ansible commands from. And you're going to use 2 hosts for testing purposes. The first host is an Ubuntu VM, and the second host is the Fedora VM. Just to clarify, Ansible does not need a dedicated host to run a service or anything like that. But we are choosing to set it up this way so that it is clear where the commands are run from. There are no specific hardware requirements for Ansible like CPU or memory limits. These could be very tiny instances with 256 megabytes of RAM. That will be just fine for the upcoming course demos. Ansible can be installed in 2 ways. One is the Python package manager, and the other is via regular package manager and package repositories of Linux. Let's understand how the Python package manager works. It is a Python utility used to simplify the tasks of locating, installing, upgrading, and removing Python packages. It can determine if the most recent version of a software package is installed on a system. The package manager can effectively install or upgrade the software package from a local or remote host. It is also known as pip for short. Pip install is the command used to install and manage software packages written in Python. In the following demonstration, Ansible is installed using the Python package manager, since it provides the latest version of any Python module. Before you use Ansible, you will need to install OpenSSH Server on all the hosts. Unlike other configuration management tools like Chef or Puppet, which have their dedicated agent daemons running on remote hosts, Ansible is agentless. Thus, Ansible requires SSH for communications between the Ansible management host and the remote hosts, which are managed by Ansible. This communication happens over SSH. So, for this communication, you will install OpenSSH, which is an open source implementation of the SSH protocols. This will facilitate secure communication between the hosts. In this demonstration, you will learn how to install and configure Ansible version 2.4 on the host machine. In this demonstration, Ansible will be installed on the localhost node using the Python package manager, or pip. On the local host, open the command line terminal. On the first line, enter the command sudo -h pip install Ansible. Execute this command. There is no password necessary as the passwordless sudo feature is enabled on this machine. You can see that the system is downloading all the required packages and their respective dependencies and installing them. Okay, great. Now Ansible is successfully installed on this machine. Verify the installation by executing Ansible -version. Execute the command. Ansible version 2.4 was successfully installed on the host machine. Now that Ansible is installed and ready, let's proceed to install OpenSSH server on the localhost node. The use of SSH is widespread today, as it provides a secure, encrypted channel for the client and server to communicate. Let's learn more about this concept. The SSH protocol employs a public key of cryptography, which requires two separate keys. One is private or secret, and the other is public. Together, they are known as a key pair. SSH key pairs are used by the host to authenticate the server it wishes to access. The key pair is generated and registered on the required servers to establish a secure communication. In order to generate key pair, you must first install the OpenSSH server on the local host. Ansible uses Playbooks, which consists of tasks and roles. Tasks are just a series of steps, which we can write to define what needs to happen in a system, and roles are more of a generic entity. You can create roles. It is a modulated version of what the task is. Once you have written a role, you can apply it to as many systems as you want. The role will be applied to that particular system as per your requirement. The example for roles are Apache server or MySQL DB server. So once you have written a role, you can apply that role to the server and the respective roles will get installed. Ansible is mainly written in Python, and most of its modules are also written in Python. And if you want to write your own modules, then the preferred language is also Python. Ansible is agentless. So you don't need to have any kind of service running on the agent node to receive Ansible command and provision it. Now, to understand what Ansible Playbook is, let's take a look at an example. This particular Ansible Playbook installs WordPress with MySQL, Nginx, and PHP FPM. Let's review this playbook line by line. Here, the first line defines the name of the playbook, and second line defines the targeted host. In this case, it is meant to install WordPress on the host server called WordPress server, while the third line states the remote user who should be logged into the remote server. The remote_user is just the name of the user account. And then we have roles. It is a list of all the roles which need to be applied onto the WordPress server node. And if you look at the playbook carefully, the first three lines denote that it is a list, and inside each list you have individual components. So this particular playbook is one individual component. If you want, you could add another playbook here. Ansible playbooks are generally written in a markup format called YAML. It stands for Yet Another Markup Language, and it is similar to JSON. The file starts with 3 hyphens. This is a hard requirement for YAML to interpret the file as a proper document. YAML allows multiple documents to exist in one file, each separated by 3 hyphens. But Ansible only wants one per file, so this should only be present at the top of the file. YAML is very sensitive to whitespace and uses the whitespace characters to group different pieces of information together. You should use only spaces and not tabs, and you must use consistent spacing for your file to be read correctly. Items at the same level of indentation are considered sibling elements. Items that begin with a hyphen are considered list items. Items that have the format of key:value operate as hashes or dictionaries. That's pretty much all there is to basic YAML. YAML documents basically define a hierarchical tree structure with the containing elements further to the left. So when you work with Ansible playbooks, you're going to work a lot with a list. This is the YAML format. This is basically the data structure and how it is represented in YAML. When you write a line with a hyphen as a prefix, it means that it is a list. And when you write a link with a colon in the key equals to value format, then it represents a YAML dictionary. In Ansible, you'll be using the list of the list of dictionary, dictionary of the list, and all these kinds of data structures. So, what is list? The list is nothing but a series of values stored in the variable, and a dictionary is similar to the list, but except that it has a key and a value. For example, here the key is the remote user, and the value is root. Another example is the key is hosts, and the value is WordPress server. It is very important to understand the list and dictionaries as the core data structures in these YAML files. As this is the YAML file, yet another markup language. You need to understand this to write Ansible playbooks. If you are familiar with JSON, then there is an option to write these playbooks in JSON as well. Also, there are lots of other tools which can convert from JSON to YAML and vice versa. But YAML is more efficient and is favored by Ansible engineers. Now, let's discuss a very important concept in the context of Ansible, the Ansible inventory. Ansible works against multiple remote hosts or machines in your infrastructure at the same time. It does this by selecting a list or subset of systems listed in Ansible's inventory, which by default is saved in the location /etc/Ansible/hosts. You can specify a different inventory file using the -i <symbol path > option on the command line. Not only is this inventory configurable, but you can also use multiple inventory files at the same time and pull inventory from dynamic or cloud sources. Suppose you have written an Ansible playbook, and now the next question we need to answer is, which hosts should we run it against? There are various options you can use to target the host, but the core element where you get the information about target hosts is the Ansible inventory. Ansible inventory is nothing but a file with a series of hosts which can be grouped. The inventory file also has different host-specific variables defined in it. In this inventory file, you can group a series of hosts together, and when you run Ansible Playbook, you can choose any of the groups or files, or you can target all the hosts in the Ansible inventory and run the playbooks against it. Inventory files are written in INI format. The INI format is a common format used to write different configuration files on multiple platforms. It has a grouping name and a series of key value elements in it. Ansible inventory also supports host variables. Host variables are variables specific to a particular host. For example, let's say you have 10 hosts in the inventory, but one of these hosts require a different username to log in. In this case, you'll specify a different username for Ansible SSH user for that particular host in the inventory. At runtime, when you run the playbook on these set of hosts, Ansible will automatically use an appropriate host username to log into each of the 10 hosts. The particular host, which needs a different username, will be picked up from the host variable, and all other hosts will use the default username as configured in Ansible configuration file. Besides that, the inventory also supports group variables, where variables can also be applied to an entire group at once. The inventory also supports group of groups. In this section, you will learn about Ansible inventory and how to create a new inventory file in Ansible. The Ansible inventory is a configured location where you can place credentials of the remote hosts, such as IP address and username. With Ansible, you can effortlessly classify or group nodes depending on the type of application being used. Ansible inventory is highly customizable and can efficiently work with dynamic sources such as the cloud. Ansible allows you to work with multiple inventory files at the same time. 2 classification rules are covered in the demonstration for creating an Ansible inventory. The first rule is classification based on the operating system of the remote hosts. In the Ansible inventory, you can classify entries based on the OS they belong to. This makes it easier to run plays or tests based on their type, rather than running individual nodes or entries. The second rule is based on the server type of the remote hosts. In this demonstration, you will learn how to create an inventory file in Ansible, run a ping test to check the network connectivity between the host and the virtual machines, and classify the information in the inventory based on the virtual machine it belongs to. An Ansible inventory can be created using any text editor or coding IDE. Here, we are using Microsoft Visual Studio Code. It is a source code editor developed by Microsoft for Windows, Linux, and Mac OS. It is redefined and optimized for building and debugging modern web and cloud applications. It is open source, free, and comes with built-in support for JavaScript, TypeScript, among others. In this demonstration, you will learn how to create an Ansible inventory and run a ping test to check for virtual machine connectivity. Let's start with the first task, creating an Ansible inventory. This is the home screen of the Visual Studio Code application. On the left-hand side pane at the top, click the New File icon next to Workspace. Name the new file as Inventory and click Enter. It opens up a blank editor page. The moment you start typing on this page, it shows Inventory as an open editor on the left-hand side pane. This makes it easy to keep track of the editors that are in progress. On the Inventory page, enter the IP addresses and usernames of both the remote hosts. This way, it informs Ansible that these are the servers to be managed. On the first line, enter the IP address of the Ubuntu VM, followed by the variable for the username, along with the input value 192.168.180.131, Ansible _SSH_user equals tetra-noodle. On the second line, enter the same variable for the Fedora VM. That is IP address, followed by a variable for username, and then the input value 192.168.180.136, Ansible _SSH_user equals tetra-noodle. The next task is to run a ping test in order to check if Ansible can access the Ubuntu and Fedora virtual machines. Visual Studio Code has an integrated command line terminal. The Ansible ping test can be conducted via the Visual Studio Code terminal. To open the terminal, go to the View menu and click the Integrated Terminal command. The top right corner of the terminal displays what language is currently being used for scripting, Bash. On the first line of the terminal, enter the command Ansible all-m ping-i inventory. The purpose of the Ansible all command is to target all servers. The -m is the M flag, used to specify the type of test, which is a ping test in our scenario. And the -i is for specifying the inventory file for the ping test. Execute the command. The response from both the servers returns successfully. There are no changes or failures. This means that both the remote hosts are securely connected and reachable. The Ubuntu and Fedora virtual machines can now be managed through Ansible. The next task is to classify entries in the newly created inventory file based on their operating system they belong to. This makes it easier to classify complex inventory files that hold a lot of information. Let's follow the .ini file format, which is a simple, human-readable file extension to specify the remote servers for each of the nodes. On the inventory file on Microsoft Visual Studio Code, enter the classification name for the remote server for the first entry. Let's say you want to classify the nodes based on their operating system. In that case, you can input Ubuntu in square brackets, and this is the classification now. On the next line, enter the name for the second classification entry, Fedora in square brackets. This is how the entries can easily be classified. You can now run any tests or plays from this inventory. To run a ping test on the Ubuntu server, navigate to the integrated terminal in Visual Studio Code. On the first line, enter the ping test command, Ansible Ubuntu -m ping-i inventory. The values signify Ansible, name of the remote server, type of test, and the location. Execute this command. The return response displays all the nodes classified under Ubuntu. If you are configuring multiple nodes under Ubuntu, Ansible allows you to easily classify them under one host and receive responses for all of them with a single command. To perform the same action for the Fedora server, proceed to a new line on the integrated terminal. Enter the ping test command, Ansible Fedora -m ping-i inventory, and execute it. The return response displays the nodes classified under Fedora. To understand the concept of node classification better, let's use another rule to classify the entries, server type. For instance, you are hosting Tetranoodle's web server on the Ubuntu VM and Tetranoodle's MySQL database on the Fedora VM. To configure the web server on the Ubuntu VM, replace Ubuntu with web server in the square brackets. To configure the database server on the Fedora VM, replace Fedora with DB server in the square brackets. To run the ping test for the web server and database server, run the ping test command on the integrated terminal below. To run the ping test for the web server, enter the command Ansible web server -m-i inventory and execute it. The return response displays the web servers configured for the Ubuntu virtual machine. To run the ping test for the database server, enter the command Ansible db server -m-i inventory and execute it. The return response displays the database servers configured for the Fedora virtual machine. Using this feature of Ansible, you have the flexibility in specifying the nodes on which you want to run the Ansible playbooks. In the next section, you will learn about YAML, the language used to write Ansible's playbooks. In this section, you will learn about YAML, the markup language which you can use to write Ansible's playbooks. You will also view how to create a YAML file in Ansible. YAML stands for Yet Another Markup Language. It is a human-readable data serialization language. It is commonly used for configuration files and applications where data is stored or transmitted. Files written in the YAML format have the .yml extension and are saved in plain text format. YAML keeps data stored in the form of a map containing sets of key value pairs. YAML libraries can be used to integrate the YAML format into several programming languages such as Python, Perl, JavaScript, etc. Integration with these popular programming languages makes it easier to use YAML in scripting. Let's proceed to the demonstration, where you will view how to create a YAML file. In this demonstration, you will learn how to create a YAML file and input information in the YAML file. Documents written in YAML make for easy-to-read data. This is useful when you are dealing with large documents that have multiple lines of data. In this demonstration, you will learn how to create a YAML file and configure data within the file. Navigate to the Microsoft Visual Studio Code workspace. Let's create a new file with a .yml extension. On the left-hand pane, enter the icon for New File. Enter the new file as test.yml. Click Enter. The new YAML file is created. Every YAML file must start with 3 hyphens on the first line. The way you write YAML code is by using something called mappings. This is nothing but a set of key value pairs, and it is synonymous to dictionaries in Python and hashes in Ruby. In this demonstration, the example used for recording input information is about a single person. Let's say we want to capture information about Michael DeHaan, the co-founder of Ansible. On a new line, enter the name key, followed by a colon. Enter the value as Michael DeHaan. Here, the name is the key, and the value Michael DeHaan is the value for this dictionary key. On the next line, enter the age key, followed by the values as 42. Next, enter the address key, followed by the value of New East Road. Next, enter the city key, followed by the value New York. And lastly, enter the country key with a value as USA. You can also enter Boolean values in the inventory. Boolean keys have 2 possible values, such as yes, no, or true, false. On a new line, enter the married key. Enter the value as true. The Boolean value is highlighted in a different color. This is because it is a reserved word, which means it has a fixed meaning and cannot be predefined by the programmer. YAML is a pretty powerful and flexible language. It not only handles scalar values, but can also handle arrays or collection of values. Let's see this in action now. Let's assume Michael DeHaan is married, and you want to capture some information about his kids as well. On the next line, enter the children key. For instances where a key has multiple values, you can add an array that holds a list of those values. Each value in the array is separated by a hyphen and added on a new line. To enter the names of the children as Kevin and Hayden, enter the hyphen Kevin on a new line and hyphen Hayden on the next line. You can add more values to a key like this. Each value on a new line following a hyphen. To record information in a single string spanning over multiple lines rather than multiple key pair values, you can use the technique of line folding. This technique is used to selectively hide or display sections of a currently edited file as part of routine edit operations. This is especially beneficial if you work on a large number of lines while coding. Line folding is denoted by the greater than symbol. To select the address values, add the hash symbol before the address, city, and country lines. The hash symbol is used to mark the key value pairs as comments. To record the information for Michael DeHaan's address in a single string, enter the address key on a new line. Enter the greater than symbol to denote line folding. Enter each address value on a new line, that is New East Road, New York, and finally, USA. This shows that the address value is recorded as a single string over multiple lines. The input information has been successfully recorded in the inventory file. In the next section, you will learn how to configure ad hoc commands and use them in the inventory file. In this section, you will learn about ad hoc commands and how they can be used to efficiently create playbooks in Ansible. The concept of ad hoc commands is a good starting point for Ansible playbooks. With Ansible playbooks, you can create complex processes with multiple automation steps in a single file. However, you may face scenarios where you implement simple tasks with just a few steps, such as installing a package, copying or deleting a file, etc. In such cases, ad hoc commands is the best solution. Using the command line tool, you can easily customize the commands based on your tasks you'd like to accomplish. The ping test command is the perfect example of an ad hoc command. This ad hoc command is used to test the reachability of the remote hosts. The all in the command starts for all the hosts that are specified in the inventory. Next, the -m stands for the M flag used to specify the type of test, which is a ping test. And lastly, the -i specifies the inventory file for the ping test. Let's take a look at a few more examples. Here are a few instances of ad hoc commands, which will be tested in this demonstration. The first command is to install a package. Ubuntu and Fedora use different package managers, apt for the Ubuntu server and yum for Fedora. In the command for the Ubuntu server, -m apt stands for the apt module to be installed on the Ubuntu VM. -a stands for argument, followed by git, which is a version control system. Git is the name of the package to be installed. And lastly, the value for the inventory file. In the command for the Fedora server, the command is the same, with the exception of the package manager, which is yum. The next command is run a bash command. The function of this command is to run a script in the bash command language. In this line, the module is command, followed by the argument, who am I? The argument used in this command returns the username of the configured remote hosts. The last ad hoc command is copy a file. The name of the module is copy, followed by the source file specified as inventory. Lastly, the destination is desktop. This command copies a source file onto a path on the destination remote host. You can easily configure and execute many such ad hoc commands in Ansible. Let's proceed to the demonstration. In this demonstration, you will learn how to configure ad hoc commands and execute the commands via the inventory file. In this demonstration, you will learn how to configure ad hoc commands and execute them via the Ansible inventory file. Navigate to the Microsoft Visual Studio Code workspace and open the integrated command line terminal. First, let's execute a ping test and test the reachability of the remote hosts. Execute Ansible all -m ping -i inventory. Here, this command is trying to ping all the hosts. -m argument specifies the name of the module, which is ping, and -i takes in the inventory argument. And now you can see both the hosts are reachable and they return positive response to the ping. The next ad hoc command is to install a package on the Ubuntu virtual machine. To install a software package using the apt package manager on the Ubuntu server, enter the command ansible ubuntu -m followed by apt, the name of the package as git, and finally, inventory. To enable root privileges for this command, add a -b flag at the end. This -b stands for become. This flag runs the command as sudo. Execute the command, The result shows the output of the installation. Git was successfully installed on the Ubuntu server. Let's run this ad hoc command for the Fedora server. On the integrated command line terminal, enter the command Ansible fedora-m yum, followed by the same value for the Git package and the inventory file. Add the B flag for this command to enable root privileges. Execute the command. You can see the result of the installation process here as well. Git was successfully installed on the Fedora server too. The next ad hoc command is to run a bash command on both the remote hosts. This command returns the username of the remote hosts. Open the integrated command line terminal. On a new line, enter the command Ansible all, since the command will run on both the remote servers. Followed by the module name as command, and then the argument who am I in quotation marks, and lastly, -i inventory. Execute the command. The result shows the username and IP address of both the remote servers. The username is tetranoodle. The next server with the IP address as 192.168.180.131 is the Ubuntu server. And the second one with the IP address as 192.168.180.136 is the Fedora remote server. The last ad hoc command in this demonstration is to copy a file on both the remote hosts. Open the integrated command line terminal. Enter the command specifying the remote hosts, followed by the source file value as inventory and the destination value as desktop. Lastly, specify that you want to run this command against hosts in the inventory file. The ~/ symbol is the beginning of a path to a file or directory, which is the desktop. Execute the command. The results show that the file was successfully copied to the desktop of both the remote servers. To verify the execution, log into the remote servers and check if the file was copied. Log into the Ubuntu server with the user password. Navigate to the desktop location. You can see that the inventory file was successfully copied. Log into the Fedora server with the user password. Navigate to the desktop location. You can see that the inventory file was successfully copied to this location as well. With ad hoc commands, you can prioritize and configure the tasks that seem critical at a given time. Let's quickly summarize what you learned in this module. You learned how to install and configure Ansible on the host machine, create an Ansible inventory using Microsoft Visual Studio Code, use the YAML format to input information in the inventory file, and configure and execute ad hoc commands in Ansible. In the next module, you're going to learn about other components in Ansible, such as playbooks, conditionals, variables, and modules. See you soon.
Hello all, welcome back to another module on Ansible. In the previous module of the course, you learned about major concepts of Ansible and how to configure them. You viewed demonstrations on how to install Ansible, create an inventory file using YAML, and configure ad hoc commands in Ansible. These demos showed you how to work with Ansible in remote environments. This module will continue to dig deeper into the Ansible feature set. Here, you'll be introduced to critical features of Ansible, such as playbooks, variables, conditionals, and package managers. Let's get started.
Let's take a look at the learning objectives of this module. In this module, you will learn how to configure an Ansible playbook by creating it and executing it to install Git on the remote hosts, variables and how to use them in the playbook. You can use variables to accomplish a number of tasks, such as finding remote host information and installing software packages, conditional statements to customize tasks, and package managers to install, upgrade, and delete packages. Playbooks are one of Ansible's critical components. They are configured to send scripted commands to remote machines. A playbook contains a list of plays, which are actions defined to configure a group of hosts. Using YAML, you can easily create a number of plays at a single time and execute them in a consolidated playbook. Playbooks are efficient solutions when it comes to configuring complex commands on multiple nodes. They are reusable and therefore greatly improve the integrity of any server infrastructure over time. In this section, you will learn how to create an Ansible playbook. You will also learn how to use the playbook to install the Git package on the remote servers. Ansible playbooks are an innovative method to run complex commands on multiple virtual nodes. Entire environments can be configured and managed using playbooks. Playbooks are written in the YAML format. A playbook in Ansible is a set of plays that are designed to achieve a certain action on specific nodes. You can configure and automate a large number of plays without having to execute them individually. A play includes tasks, which is a set of actions designed to achieve the goal of the play. Plays that are configured in a playbook are sequentially implemented. You can configure multiple tasks and subtasks within a specific play. Plays are highly flexible and reusable artifacts. Tasks are a subset of plays, used to implement specific steps in a play. All tasks call an Ansible module. Remember that Ansible modules are components that do the actual work for Ansible. These are what gets executed in each playbook task. These modules control system resources, such as services and packages, and even handle system command executions. It is exciting to note that each module in Ansible calls a Python script in the back end and performs all tasks on the remote hosts. Ansible boasts of a large number of built-in modules, such as Package Manager, Services, etc. The Package Manager module is used to install software packages. Also, the Services module is used to control system services on the specified nodes. Did you know that you can also create custom modules to suit your configuration needs? In the demonstration that follows, you'll view how to configure and execute a playbook on remote hosts. In this demonstration, you will learn how to create a playbook and use it to install Git on the remote servers. In this demonstration, you will view how to create a simple playbook in YAML using Microsoft Visual Studio Code. Git is currently not installed on both remote servers. To check this, let's log into the remote servers and verify. Log into the Fedora remote server and navigate to the command line terminal. Enter the command git followed by 2 hyphens and then version. Execute the command. The result shows that the git command was not found, which means that the package was not installed on the Fedora remote server. Let's verify on the Ubuntu remote server. Log into the Ubuntu server and navigate to the command line terminal. Enter the same git command, git 2 hyphens and then version. Execute the command. The result shows that the git package is not installed on the Ubuntu server as well. Let's proceed to playbook creation. Navigate to the Microsoft Visual Studio Code workspace. On the left-hand pane, click the new file icon. Name the new playbook as install_git.yml. Click enter. The new playbook is successfully created and is ready to be configured. You will now view how to create plays in the playbook. For the purpose of this demonstration, 2 plays will be created. The first is to install Git on the Ubuntu server, and the second play is to install Git on the Fedora server. Open the install_git.yml playbook. On the first line of this file, enter 3 hyphens, as this is a YAML file. To create the first play, enter the name key, followed by a colon, and then enter install Git on Ubuntu. This is the name of the play, and it helps you organize the playbooks and make them more readable. The nodes in the inventory file are configured as Ubuntu and Fedora, as demonstrated in the inventory file. On the next line, configure the hosts for the play. Click the spacebar twice and enter the hosts key, followed by a colon. Enter Ubuntu, since this play will install Git on the Ubuntu server. In order to execute the playbook on the remote server, you require root privileges. In order to enable the privileges, on a new line, enter the become key, followed by true. This command defines the user as root and enables the root privileges. To configure tasks for this play, enter the tasks key on a new line. There are multiple tasks for this play, and therefore they must be listed in the form of arrays, each task on a new line followed by a hyphen. On a new line, enter a hyphen followed by the name of the task as install Git. Each task calls an Ansible module for execution. On the next line, enter the package manager for the Ubuntu server, which is apt, followed by the name of the package to be installed on Ubuntu, name equal to Git. The first play of this playbook is ready. Let's create the next play for the Fedora remote server. Enter the name of this play as install Git on Fedora. Enter the hosts as Fedora. This play will install Git on the Fedora server. To configure tasks for this play, enter the tasks key. Next, enter the name of this task as install Git. Enter the package manager for Fedora, which is yum, followed by the name of the package to be installed, name equal to Git. Both the plays are created, and the playbook is ready to be executed. Except for one thing. You need root privileges to install these packages on the remote hosts. To enable root privileges for the user, enter the become key followed by true. Ansible allows you to become another user, different from the user that logged into the machine, the remote user. Let's add the become directive to both plays. To execute this playbook, navigate to the integrated terminal on the workspace. Enter the execution command Ansible-playbook, followed by the name of the playbook, which is install_git.yml. Lastly, enter the inventory flag, -i inventory. Execute this command. You can view the progress of installation on the terminal. The play is being executed on the Ubuntu server. The execution is gathering facts about the remote server, such as CPU space, RAM speed. The changed status of the task shows that something has changed on the remote host. And usually it signifies that the play was successful or Git is successfully installed on the Ubuntu server. The execution has now moved to the Fedora server. The execution gathers facts about the Fedora server as well. The changed status of the task shows that Git is successfully installed on the Fedora remote server as well. To verify the installation, log into the Fedora remote server and navigate to the command line terminal. Enter the command git followed by 2 hyphens and then version. Execute this command. You can see that Git version 2.9.5 is available on the server. To verify the installation on the Ubuntu server, log into the server and navigate to the command line terminal. Enter the same command, git 2 hyphens and then version. Execute this command. Git version 2.7.4 is now available on the server. This shows that the playbook execution was successful. In this way, you can easily configure and execute multiple playbooks in Ansible. In this section, you will learn how to configure variables in Ansible. Although Ansible is a highly efficient programming software, it does not contain all features required for programming. Still, it is compatible with many aspects of programming language. One such aspect is variables. These are similar to container, holding some value and can be reused multiple times. Ansible uses variables to provide flexibility in playbooks. Variables benefits include the ability to loop through a set of given values, access information like system hostname, etc. However, there are some restrictions for variables in Ansible. Variable names should include letters, numbers, and underscores, and they should always start with a letter. Now we will discuss the facts variable. Ansible by default collects information about the remote hosts and stores them in a dictionary variable called facts. Note that the facts variable is different from other variables because it is not set by the user. It is discovered by Ansible when it connects to the remote hosts. Ansible variables are mainly used to write the playbook optimally. When you use variables in your plays, it avoids you having to hardcode any of the values in the play. For example, if you are writing a play for WordPress installation and you want to specify that you want to run your WordPress instance to run on a different port other than 80, then rather than hard-coding the port number, you can just create the variable to hold the value of the port. Say you need to use this port number in multiple places in our playbook, for the web server, for firewall, and for some other configuration changes. Rather than repeating the hard-coded value all over the place, you can just use the variable instead. Now, in the future, if you want to make a change to the port number value, you do not need to scan the whole playbook and make numerous changes, just change the value of the variable, and you are all set. Most of the variable naming conventions which apply to other programming languages remain consistent in Ansible, especially the conventions followed by the Python platform. There are certain rules for the variable names that you must follow, like you cannot use hyphen in a variable name. The variable name can be alphanumeric, but it should start with the alphabet, not with a number. Variable names cannot contain spaces, and certain other special characters are also prohibited, like ampersand or percentage. In the upcoming demos, we are not going to use any complex name for the Ansible variables. Variables can also be grouped together in a file, say a configuration file. So, where can you define your variables? You can define your variables in the inventory file, which by default is located at /etc/Ansible/hosts, as you saw in previous sessions. You can also use them in Playbooks. Files. You can define your variables in a separate file and include it in your Playbooks. At runtime, Ansible will be able to pre-process the variable files and include the information contained in them. Roles are the best way to organize your playbooks. Roles are ways of automatically loading certain vars underscore files, tasks, and so on, based on a known file structure. Grouping content by roles also allows easy sharing of roles with other users. You can use variables in roles as well. In almost all configuration management tools like Ansible or Puppet, there are these things called facts. In the context of other tools, its name may be something different. For instance, when you use Puppet, you call this fact as Puppet factor. So, what is an Ansible fact? Well, a fact is a detail or piece of information collected from a remote host. Facts are information derived from speaking with your remote systems. These facts can be used for your playbook for various purposes, like for grouping nodes. Ansible uses facts, which is mainly system and environment information. Ansible gathers context before running tasks. Ansible uses these facts to check state and see if it needs to change anything in order to get the desired outcome. This makes it safe to run Ansible tasks against a server over and over again. For an example, suppose you have a big data center with 1,000 nodes, wherein each node belongs to a certain category or certain operating system. Ansible facts will basically provide a whole bunch of details about any particular host. It provides the details like IP address of the system or IP address of all the interfaces, the OS details, the kernel details, or the hardware details. It will basically provide all the basic system information, which you can use in your playbook to perform operations against it. For example, if you need to collect details of all Ethernet 2 IP address in a particular group of hosts, in that case, you'll be using Ansible facts, because in the inventory, you might be having host name or the Ethernet 0 IP address, but at some point, you may need to make some configuration changes for a particular software, and you need to use Ethernet 2 IP address. So, in that, you'll be using Ansible facts to get all those details. So, a question arises. What can all the information Ansible facts provide? And how exactly can you obtain it? The answer is Setup module. Ansible provides a module called Setup, which can be used to collect Ansible facts. Usually, these facts are discovered automatically by the Setup module in Ansible. Users can also write custom facts modules. Let's take a look at an example. $Ansible all-m setup. If you execute this command, it will get all the facts from all the nodes in the inventory. This will return a ginormous amount of variable data. And if you want to filter a particular category, you can specify a filter using -a parameter and select a particular category from the facts that you're interested in. $Ansible all-m setup -a gather underscore subset equals network virtual. So if you look at the filtered facts, you can see you are trying to filter the facts and restrict the additional facts to the given subset. One thing to remember here is when you run a playbook, the first thing Ansible does is to collect all the facts from all the hosts. So this fact collection takes some time to execute, especially when you have a large number of hosts configured, and moreover when the hosts have a lot of details to provide. And if you are very sure that in your playbook, you aren't going to use any of the variables from facts. For example, as mentioned earlier, you're going to collect facts from Ethernet 2 IP address to make some configuration changes in the software. Suppose if you're going to use Ansible facts here and you'd like to do a plain Ansible script. In such situation, you can just ignore the facts. You can do so by configuring a setting called gather_facts to false in the playbook. Once this is done, Ansible will not collect the fact for a playbook. So in this case, when Ansible plays the playbook, it will not bother with fact computation. Setting gather_facts false on a playbook allows this implicit fact gathering to be skipped. The advantage of doing this is it will run faster, and the disadvantage is you will not be able to use any of the Ansible fact variables with that particular playbook. After configuring variables in a playbook, we move on to conditionals, which are an interesting concept in Ansible. Conditional statements are used to inform the program what commands to run based on certain conditions. Quite often, the result of a play depends on the value of a variable. While you have the flexibility to control the output of a play with a variable, it may seem cumbersome to keep track of each variable's result. If-else statements are conditionals that help control the execution flow of plays in Ansible. These can be used with a Boolean condition of yes, no, and true, false. These conditionals trigger a program to execute actions based on the true or false condition. The when statements in Ansible are used to perform actions only on a few of the configured hosts. It helps you skip steps in a play so that you can execute the necessary tasks. Guess what? This increases efficiency and scales up your development process. In the demonstration that follows, you will learn how to apply conditionals in a playbook by executing the when statement. In this section, you will learn how to configure package managers for different tasks in a playbook. We all know that modern software comes bundled in packages, which makes managing the programs installed on your system easy. These packages contain software metadata and dependencies to ensure that the software runs smoothly. Package managers make it easy for you to automate the installation process of such software packages. Using package managers, you can securely download and install packages, keep track of software versions, avoid overwriting software files, and delete packages. Package managers allow you to optimize the software installation process in multiple environments. Let's dive deeper into this concept. A package manager can be defined as a collection of software tools for automating the process of installing an application. Package managers are also known as repositories. Easy automation of the entire process. Modern software is advanced and is made up of a large number of components, dependencies, and metadata. These include source code, software information, documentation, and shared libraries. Package managers automate the entire process of installing all these components onto your system. They are designed to eliminate the need for manual installs and updates. This can be useful for large enterprises whose operating systems are based on Linux and Unix-like systems, consisting of many distinct software packages. Packages installed via a package manager ensure consistency among other packages and contribute to the overall stability of a system. With a package manager, you can install packages onto servers, update caches that store package information, perform upgrades of configured repositories, keep track of all versions of the application, and delete packages. Two popular package managers used in the Debian and Red Hat systems are apt and yum. apt offers a concise interface to common operations that are otherwise handled by the traditional package managers of Debian. Yum is used to interact with individual packages as well as repositories. Let's quickly summarize what you learned in this module. You learned about how to create a playbook in Ansible, how to configure and execute the playbook by creating plays and tasks, variables in Ansible, facts variable in the playbook to gather facts about the remote hosts, conditional statements, and package managers to install, upgrade, and delete packages from the remote servers. These concepts enable you to efficiently install and configure complex software on remote environments. You can customize the Ansible playbooks to fulfill your automation needs and achieve the desired results. Ansible helps you accelerate your business process by increasing delivery and profitability. This also brings us to the end of the course. In this course, you learned all about this excellent automation framework called Ansible. With Ansible, you can securely and effortlessly scale up your automation goals and maximize your business profitability. We hope you enjoyed this course and found this information useful. We also hope you had as much fun learning about Ansible as we had putting together this course for you. Let's stay in touch. You can also connect with us directly via LinkedIn, Twitter, or email. We'll be glad to help you out in any way we can. Please do not forget to leave a review for this course. It will really help us and other learners. Please do check out our other top-rated courses we are offering. There are many special offers available for you in the last bonus lecture of this course. Please consider it as a token of appreciation for our current students.
Hello there, and congratulations on finishing the course and making it to our very special bonus lecture. You get an E-Gold Star. Thank you so much for enrolling in our course and making it all the way to the end here. We want to share with you information about some of the other educational resources that we have built. Since you've taken this course, we would love to see you in many of our other courses, and we want to give you the absolute best value and create an awesome win-win-win situation. You get smarter, our courses get better, we sell more courses. It's a win-win-win. Here are all the courses that we have published so far, and more are being worked on as we speak. Well, I speak and you listen. We also have a website, www.tetratutorials.com, where we publish these courses. In the coming months, you can expect this list of courses to grow and multiply in numbers. One thing that we can guarantee is that we will strive to bring you the most useful and relevant information in all of these courses. Taking one of these courses will improve your life, be it a better job or getting a promotion or gaining a much needed skill set to launch your next idea. As lifelong learners ourselves, we know that as a student, if you enjoyed working with a group of instructors and really benefited from taking one of their courses, chances are that you will really enjoy taking another one of their courses. Think of it as watching another episode of your favorite web series. And since you've already done that with one of our courses, we would like to share more information and knowledge with you. Like I said, we're geeks and we love sharing knowledge. We want you to really feel good about enrolling in another one of our courses. And to help you along and show you our appreciation for you being you, we are extending this special discount to you. You can use this coupon on your screen for any of our courses and get an exclusive deep discount. Here on our website, you can find all the relevant links to our social media channels, as YouTube, Twitter, LinkedIn, and so on. And we also have a blog here where we share relevant information. So please check that out as well. While you're here, please sign up for our newsletter as well. We regularly send updates about our courses, industry news, and sometimes special discount coupons in the newsletters. So it's a great way to stay in touch with us. One more thing. We would really appreciate it if you could provide us with honest feedback and leave a review for this course. Good or bad, we will love to hear from our current students and continue to improve our content based on the feedback. This not only helps us, but also all the other students like you who are looking for similar content. So by leaving feedback, you are making the world a better place. We are really looking forward to hearing from you and to continue to serve you. Thanks a lot for taking this course and watching this video.